Um, I welcome you to this meeting, to this series of meetings organized by the department. The aim is to help our faculty position themselves in this new structure, I would say. For us, it is a chess game. It's rather a chess game because we are a little bit confused and we may be in different centers at the same time. So we need to choose only one. It seems from the last email, they are saying only one. Only each faculty must be affiliated to only one research center. Anyway, today we have Dr. Ahmed Surur. We thank him very much for accepting our invitation and for talking to us. We will hear from him about the kind of mathematics they are using in his research center, and what is expected in general from affiliates or from, especially from mathematicians. He will take all his time for a presentation, and then it will be followed by an open discussion. Dr. Ahmed, the floor is yours.
Okay, thank you. Thank you. Assalamu alaikum jami'an. Good morning, everyone. Yeah, we'd like to give you an overview about the Interdisciplinary Research Center for Advanced Material and what the expected contribution from math department. And maybe I will end my talk with how you can either affiliate to the center or be members for collaboration with us, inshallah. So this is just give an example of the challenge that we are thinking to address. For example, as a center to address maybe to engineer materials to exhibit novel property that lead to super performance. Maybe we do some material development to increase the utilization of hydrocarbon-based material like polymers and polymer composites. And this is good for the kingdom to increase the demand for oil other than to be used in energy. We also would like to add to extend the product lifetime and durability by reducing the material degradation, corrosion, wear, failures, etc. We also want to do material development and material research and development to contribute to reduce the maintenance, fuel, or energy consumptions. Like, for example, when you develop new light alloys that will be used for a vehicle to make the weight less, and then consequently, you will reduce the fuel and energy consumption, also to reduce carbon dioxide emissions and waste. Also to turn waste, like for example, tire, into useful material like carbon fibers. Preserve and extend shelf life of food and beverage by developing new packing, maybe new inhibitor, etc., and other challenges. This is the theme that we're expecting to start with. And we will see how it will be progress. Some of these already will establish at previous center like corrosion or other departments, and some is kind of a new like hydrogen storage material. So we are expecting to contribute in coating and surface engineering, considering all type of material like polymers, metallic, ceramic, etc. Smart material, the material that are behave as a function of voltage, light, or other external force. Lightweight materials, like in metals like aluminum, magnesium, titanium, this lightweight, which we use for aerospace, for automotive. Polymers, also polymer composite, considered as a lightweight materials. Biomaterials, the material that will be used for implants, for example. Corrosion scale inhibitors. It's a chemical additive will be added to the process, mainly for industry process, to reduce corrosion or scale formations. Material selection and design. So we will, and here maybe most of the mathematical application can be in this area to select the best material, designing the material, etc. I can give maybe more information. Hydrogen and storage materials. So develop material to store hydrogen, not by high pressures, but by like metal hydrates, etc. There's some kind of material used for that. And material for extreme environments like high temperature, severe corrosion, high salinity, high radiation, etc. So if later on, if any faculty is interesting for a specific area or he think he can contribute, I can give more detail. Or even if you have time today, I can give more detail. But here is what would be the possible contribution of the math department to this center. I think we may need applied mathematics, statistics, and experimental design. So for example, applied mathematics would help to solve ordinary partial differential equations to define physical systems for modeling, like in material or mechanical applications. Statistics and experimental design would help to design complex experimental setups for understanding multiple parameter effects and their analysis. Also can be helpful in validating electrochemical data generated from experiments and, for example, corrosion data from a field study. Okay. We may also need data science who will help in the big data analysis for field data used for machine learning. I will give one example here. For example, if you want to study the corrosion of one part for car, maybe the one in the bottom, for example, we could attach a sensor to a number of cars, and then we monitor maybe corrosion rate or read the corrosion rate during the year. Maybe take the reading maybe every day or every week or whatever. So we will end up with a huge number of data. That may need a lot of cleanup, some analysis, maybe organization. I think we will need data science and statistics in this area. Yes, we have corrosion expert, we have material expert. Maybe we will have machine learning expert, but maybe data science is missing here. Also, we are expecting to do machine learning and AI applications in material design. So designing the material, for example, selecting the best material for specific applications, and also doing risk assessment. Again, here we will need maybe statistics, data science, etc. We have activities in the computational materials, like density function theory, Monte Carlo simulations, molecular dynamics. I'm not sure if math also can contribute here. Here also we have Dr. Amy with us. He has subject matter expert in this area. Maybe we can discuss that. So, okay, this is the expected contribution. I think one way is for the faculty to be affiliated with the center if he think he can contribute to many projects. That will be clear case. If someone is not sure for now, it's still he can collaborate with us. He can be members of some of our projects. Maybe later on he can be affiliated. So now we are in the process to receiving proposals from the affiliates. We have number of affiliates now. Up to date, we have 23 faculty joined the center, in addition to 8 full-time researchers already in the center. So we have a total of 32 members. All are PhDs. And now they're starting submitting the proposal to be funded by the center. So maybe the faculty can join either as an affiliate or a members. Doesn't need to be affiliated to the center, or he can be even affiliated to other center and join us as a members. But if you think his contribution will be significant, no, I think to be affiliated, that would be much better. So this is in brief. Now I think if you have any question, we can now discuss it more. I can elaborate more in any items here. You are muted.
Thank you very much, Dr. Ahmed. Thank you very much, especially for this last slide, where things are somehow, to some extent, clear to us. So floor is open to questions. You can open your mic and speak, or raise your hand. In the meanwhile, let me ask you, Dr. Surur, so you don't mind that someone joins the center and works on his own project?
Well, but what do you mean by his own project?
A project he is working on, for instance, he's working on an analytic part or theoretical part of something which has an application to advanced material, and he has his own project, which, for instance, has been accepted, or he's gonna.
Yes, initially is accepted, of course. Maybe somebody has already well-established area, and of course he would like to continue. It's okay, but later on he needs to be aligned with the center strategy. Now this is the main objective of these new centers. Actually, now before the faculty, every faculty can do his own research in his own direction, which is not wrong. It's good, but you know, the impact will be not, it will be low, because everyone going his own directions. We may have some impact. In very rare cases, some faculty grouped into work together and have maybe better impact. But now we would like to have a number of centers, and each center have his own strategic research strategy and agenda, and it should be aligned with the national strategy also. So we will have more support. We are aligned with what the country is looking for. So we will have more impact, and now people from different departments will work together. For example, now in advanced material, we have faculty from mechanical, from chemistry, and from physics. We have one from electrical engineering, and yeah, these are the department now are involved. So later, no, if the faculty will be affiliated, he should be aligned with our strategy also. So his application should be one of these themes.
Yeah, we understand that his work must be somewhat related to one of these themes, yes. Any question? Dr. Khalid?
Yeah, Assalamu alaikum, Dr. Ahmad.
Alaykum assalam.
Okay, going to this slide where you listed the needs, and what drew my attention is the first item here, applied mathematics, and we're talking about deterministic continuous models and so on. First of all, such centers, it seems mostly they are technology-based centers, I mean, to develop certain material solutions and so on. I want also to see to what extent you entertain some fundamental basic research related to these technologies or smart material, whatever. And for example, here when it comes to considering mathematical models of this type, deterministic continuous equations, to what extent this will be really considered in the center. For data science, machine learning, big data, all of these issues are clear. But the first item there, if you can give us more details, please.
Okay, for your first question about yes, from the first day, yes, the center will going to conduct both basic and applied research. So it's not only applied or technology development to finding a solution. No, we will also doing some basic, but that are aligned with the focus area that we are, or it should be aligned with the challenges that we will address. And we will every year we will identify maybe 4 or 5 challenges. So if you're going to do basic research, it will be, related to this challenge, not like open-ended. So yes, we will do both basic research and applied research, both. For the second question about solving the equations, to be honest, I cannot elaborate more here. Actually, I'm not numerical expert, or almost all of my work is experimental work. So I personally cannot maybe elaborate a lot more here, but I get this suggestion from one of the faculty from mechanical engineering department that maybe the contribution of solving these equations for modeling or system, that will be. So this will be depends on the project. Later on, if you have a project,
may I add, Dr. Surur?
It can be discussed later. Yes.
May I add something to this, Dr. Surur?
Yeah, go ahead.
Yes. So I actually was one of the faculty who proposed this idea of differential equations. So in applied math, as you know, Navier-Stokes or other types of equations are used to solve or model complex physical phenomena. We have the Euler beam equation, we have the Navier-Stokes equation, we have the damping spring equation. They are used to define all different types of mechanical systems. In our case, we have mechanical and also material systems. So in material systems, we have equations that define the corrosion behavior, like Dr. Surur mentioned previously. So most of the modeling works on that. Now, in the faculty of math, of course, is experts, have experts in finding the solutions of these equations. Many of these solutions, as you know, do not exist. For example, Navier-Stokes is not solved yet. So we need to we are always looking for new applications and ways to solve these equations to help our understanding and also to help us in modeling. We can model them. We have various softwares and in-house codes, but there's always a better way of doing it. And I think there are many faculty here that can help us in doing that. Just wanted to add that.
Yeah, thank you, Dr. Ahmad. Yes. I thought you are not attending with us, but okay, thank you.
Okay, that will be great. I think this is one of the areas where we can find many things in common. Maybe by sharing the challenges you have in some of these issues, I'm sure, as you said, in math we have some, we have some colleagues here where they might be interested in this venue of research, let's say. Okay, thank you so much.
Yeah, in fact, some of our faculty are working on vibration reduction for beams, strings, and plates, for instance, where they use the vibration and with some delays or viscoelastic material and so on and so forth.
Okay. But also our scope is not purely mechanical because this is like advanced material center. But yes, there is some mechanical issue. But also there is a lot of applications. Mechanics is, for example, we have talking about like indentation, like the contact mechanics, talking about plasticity, elasticity. I think there's a lot of applications here for math. Maybe Dr. Ja'far can also elaborate more about plasticity and elasticity.
Yes, thank you, Doctor. If I may add something here, I think one of the main reasons why I was looking forward to this meeting is to know who is among our mathematician here in the university is interested in the idea of working with us, mechanical engineering or any other engineering department. As Dr. Ahmed pointed out, if we put maybe the plasticity aside, there is a new let's say theory which is called paradynamics. I don't know if you are aware of it, and I know that there is so much mathematics going on the theory than even engineering. My whole idea here is to know how can we now establish this connection. I have ongoing work, not in paradynamics. This I'm working on the theory. Maybe within the coming period, I will pick up some good level of understanding of it. But I have some ongoing work, which is now, and I honestly spent a year thinking about talking to somebody in the math department, but I can't talk to the entire department, right? And maybe I don't know by whose I should talk to just by looking at your profile in the website or even checking your published paper. And maybe I thought that this is a good arena today to establish some sort of communication. I can write something in brief, and if anybody seems to be interested, this is where the starting point start. That's only the comment I want to add, and I will leave the floor now for anybody who want to say something.
Dr. Jafar, assalamu alaikum. Thank you very much for this comment. In fact, this is just a first round where we listen to you. And most probably there will be a second round of meetings with you where you listen to us, where every faculty who's interested in these subjects, he will present the problems he is working on, the techniques and so on, and it is up to you to see if this is close to you or not, if this is interesting for you or not. So we are thinking of perhaps a single workshop with all the directors and our faculty will present their work. As you know, we mathematicians sometimes work on a single problem which has applications in dozens of fields. As you know, differential equations, for instance, have application, or integral equations or whatever, have applications in civil, in mechanical, in electrical, in biology, ecology, medicine, various types. So we are thinking about organizing such a workshop in the reporting period. So how likely would you be interested in hearing us, in listening to us in a workshop in the reporting period?
If that's a question to be answered, yeah, I would be very, very much interested. Honestly, I am still serious about checking any of our mathematician here, the colleagues, to see if there is a possibility to join me on my current work that I mentioned. I don't want to get into the details right now, but I'm very much interested, honestly.
Yeah, this will avoid you to go to each faculty. So we'll have our faculty, they will show you their skills and the kind of problems they are working on, and you will see how much close you will be. Dr. Khalid?
Okay. Well, I'm happy to hear this comment from Dr. Jafar. This is exactly the thing we are looking at. As he mentioned, for example, period dynamics is recently, for the last 2 or 3 years, is a very hot topic, and there were many events organized by just to tackle these issues. And usually, you'll find there people from mechanical engineering, material science, and mathematics. Now, for example, if you search our profiles, maybe it's not easy to locate from our expertise what is related to this area. But for example, in the theory of period dynamics, recently is tackled more with what is called nonlinear operators, fractional operators, and so on. And this is actually one of the strength areas in the department. So I'm glad to hear that, and I'm sure similar issues can be related to the expertise of the math department. Sometimes we need to use the right vocabulary to match the name of the application with the name of the tools in mathematics. But yeah, this is an example where, yes, we have expertise in the department that can utilize the different tools especially the fractional operators and so on, to model these complex materials, smart materials, and especially this kind of peridynamics approach. Yes.
Okay, thanks, Dr. Khalid. Any other question from the faculty?
I also hear Dr. Amy Obot and Dr. Rami Sleiman, you did some work in the computational materials. I'm not sure if you would like to say anything here, some detail maybe about the example of the contribution of math and statistics.
Assalamu alaikum.
Alaikum assalam.
Alaikum assalam wa rahmatullah.
Yeah, this is Dr. Rami Sulaiman from the center. I would like to emphasize here that what Dr. Ahmad highlighted, that having a faculty from the math department of statistic background will be highly beneficial to the research we are conducting on corrosion, because in corrosion analysis we use heavily the electrochemical techniques, and a lot of electrochemical data generated from this research, especially the part related to electrochemical fitting of the data. And I think the input of an expert statistics on specialist on the data generated, and any also conclusions can be drawn about the validity of this data will be very helpful. In addition to that, I don't want to to go talk about corrosion inhibitor, because my colleague Dr. Amy will talk about this. But for the coating system, sometimes we develop new coating systems, and we are interested to understand the electrochemical properties and the electrochemical interactions between the coating and the substrate, and to build a physical and mathematical model for this interaction, and later on to fit it with the experimental data. So I think here we feel a high need for also a faculty of experimental design and modeling background to our research.
Thanks, Dr. Rami. Thanks, Dr. Rami. But I think the question of Dr. Ahmed was about people working on numerical analysis, numerical computational things. We have quite a good number of people working on numerical analysis.
Okay, so
yeah.
Dr. Amy, would like to say anything here? Or?
Yes, thank you so much, Dr. Ahmed, for the meeting. So okay, let me start with this computational material science. So this has to do with condensed matter physics, more or less. So it's more of a physics problem, although mathematics are also involved, but more of condensed physics. So it has to do with using density functional theory to solve some problems in materials, in chemistry, and even in physics. So though we have softwares that we can utilize to do this, but I think the in advanced material we work less on the theory, on the development of the theory itself, because the theory is highly mathematically involved. So we work more on the on the softwares. But the area I will really need a collaboration. It will be machine learning, how to use machine learning to analyze historical data, because for example, you have so much data, and then you want to learn from the data. So machine learning is very, very important in this regard, because we generate a lot of data, corrosion data. For example, Aramco has a lot of historical data that they have. So they want to learn from this data so that they could plan well. They can also predict risk. They can do risk assessment of their pipelines. So this is an area that we will need people from statistics, people from mathematical department to really collaborate with the center, so that they can bring their expertise to find solution to this problem.
If I can say one more thing here, that related to computational materials, we are relying on the available software and the platform like Material Studio and others, which is already maybe developed by part of it by mathematics. So I'm not sure how now Math will do we need really to develop new theory? Do we need expert in math? Actually, I'm not sure. And what Dr. Rini said, he's utilizing the software, and the software is doing what he is looking for. So I think the math expert should tell us now what they could do.
I think in this area, I think what mathematics expert will do is in the modeling. Determining maybe, for example, in a nuclear plant, we can determine how long it would take for to store a nuclear material. So how long it will take. So this kind of question can be is a form of deterministic kind of question, so which can be solved by mathematical modeling. So I think this is a major area that we can have collaboration, and if somebody is interested, I can share with the person some of the problems that can be tackled using this kind of mathematical modeling. So for numerical applications, so I don't I don't have expertise in this area, so I don't know much about it.
Yeah, thank you, Dr. Ini. Thank you, Dr. Jafar. Yes, indeed, using softwares and toolboxes already established. This is for old problems. This is for where mathematicians can help is to improve these models. If you want to take, for instance, in a model, let's say you want to take delays which occur and which are not in the actual softwares and toolboxes. This is where mathematicians can help. They will establish the robustness of the system, and they can put it in a software or something. But softwares which already exist are for basic problems. Now, if you wanna improve these basic problems, you need mathematicians to establish at least the stability of the system and to put it in a software. But available softwares are for us. It is for all problems. So if you want to improve these problems, for instance, consider a certain fractal media, or take into account some new external forces like disturbances or like delays or things like that, you need the mathematicians, because you cannot find these things in a software.
Yes, yes. Thank you so much. But I understand what you say. But there are a lot of software. There are types, so it depends on the application. So, like I said, the kind of software I'm talking about is for materials. For like molecular modeling. So there are types. There are, for example, like MATLAB. It does a different thing. compared to maybe like Material Studio. So when I say software, you know, there are types of software, and also this software, you know, there are new version every year, like you said. So it is undergoing further development. You know, but the area which I think mathematics will be very useful for us might be, like I said, in the numerical modeling, and also in machine learning, which is which we need in terms of you know, getting all the data that we have, trying to use algorithm like artificial neural networks, deep learning, all these kind of areas, so that we can get understanding, or we can also predict future events. So these areas, I think, is very, very important. Thank you.
Thank you, Dr. Amy. Any other question from the from our faculty? Just one example, most of the softwares used, for instance, in the continuous or the deterministic problems, they use first order derivative or second order derivative. I mean the change of in time. If you go to fractional, for instance, you will find very few software. If you have fractal media, complex media, which needs fractional order derivatives, you cannot find much in software. Any question from? Okay, so if there are no questions.
Also, maybe I will add one more area that I worked in it for a few years ago, related to numerical for thermodynamic of materials, numerical method in thermodynamic of materials. I used one software called FoxEdge. There's like a comprehensive database for that, and it's all upgraded every year. So. But still, maybe math can contribute also in the thermodynamic of materials from numerical point of view, not analytical. Okay. Yes, sir.
Any question? Okay. So as I said, this is just a first round of meetings. We will keep in touch. For sure, some people will contact you individually to express their interest in your center, and we will perhaps meet one more time in the reporting day, inshallah.
Inshallah.
Reporting period, inshallah. With that, thank you very much, Dr. Ahmed. Thank you very much, Dr. Amy, Dr. Jafar, Dr. Rami.